Back in like 2010, I discovered a SuperCollider tweet by Nathaniel Virgo, posted as @headcube, that caught my attention, and it sounds like this. Link in the video description. Go check it out. Listen to some of the other ones too. They're all fantastic. As an exercise, I like to deconstruct these to understand them better, so feel free to pause and study this exploded version at your own pace. Back then, there was one part of this tweet that I could not figure out, and it was this here, x space asterisk period x space x. My reaction at the time was, well, this is complete nonsense. I forgot about it for a while until like a decade later, I posted a question on scsynth.org. Mystery solved. Turns out it's pretty interesting. So this x and this x refer to this array of arrays of numbers. This asterisk means multiplication, like it usually does, but this dot x here is called an adverb. It's an additional argument provided to the binary operator that changes its behavior. A binary operator being some symbol or method that applies to a pair of values, like this plus that, this to the power of that, etc. Adverbs are documented in a file called Adverbs for Binary Operators, and this concept also appears in a file called jconcepts in SC. And by the way, the fact that the array and the adverb are both named x is, in fact, a total coincidence, which is kind of confusing, so you can rename the array if you like. So here's the deal. In SuperCollider, a binary operation with a number and an array is defined such that the operation is applied to the number and each item in the array, resulting in a new array of the same size. For an operation with two arrays, the default behavior is to apply the operation to corresponding pairs of items, and if the sizes of the arrays are different, wrap to the beginning of the short array and start over as many times as needed to accommodate the longer array. So in this case, we get 100 plus 1, 200 plus 2, 300 plus 3, and then we wrap the shorter one and we continue with 100 plus 4, 200 plus 5, etc. Adverbs change this default behavior. .s stands for short, which means the shorter array determines the length of the result. .f means folding instead of wrapping, so when we get to the end of the short array, we bounce back and go the opposite direction, bouncing back and forth as many times as needed to accommodate the long array. So here, notice the hundredths place goes 1, 2, 3, 2, 1, 2, 3. .t is table. This is where things get interesting. The result is a multi-dimensional array. So in this case, an array containing 3 arrays, each containing 7 numbers, and the operation is applied for every possible pair of values from the first and second array. .x, which I think means cross, almost the same as table, except it removes the inner brackets and the result is just one large array. And keep in mind this syntax works for any binary operator with a symbolic representation, like subtraction, division, modulo, whatever. But for operators that don't have a symbolic representation, for example, least common multiple, the syntax needs to be a little bit different. You can either put method : dot adverb between the arrays, or you can do receiver dot method style and in parentheses, comma after the second array, followed by a symbol representing the adverb. So cool that you can modify this behavior, but not immediately clear why it's useful, and where I think this trick really shines is generating pitch collections. Let's say you want to generate a list of all the MIDI notes on the 88-key piano keyboard that belong to the key of A minor. We can get the raw scale degrees like this, and note numbers on the piano range from 21 to 108. So here's one way to do it. It's maybe not the most optimal, but it works. Start with an array of a bunch of octave transpositions and cross-add with the minor scale, and then add 21 to start on the correct note. 127 is higher than we need, so we can use reject to iterate and remove anything greater than 108. And there you go. So hopefully you can imagine all the complex and interesting data collections you can concisely generate with these adverbs. And by the way, if you one day find yourself with a lot of caffeine and nothing else to do, I recommend you browse this jconcepts guide because some of the stuff in here is pretty cool. So thank you to Nathaniel Virgo at Headcube for letting me feature this awesome tweet. And very special thanks to my patrons for the support. Much appreciated. And to everyone, hope this helps. Thanks for watching.